This is exciting. It's been some time to be able to actually stand on stage. As we all know, well, COVID happened. I've done a couple of online presentations the last years, but actually doing this physically, it's a right pleasure. You're the first one for me this year, so I hope I'm definitely going to enjoy it, and I hope the same will apply to all of you. I'm Steven. I work at Axonic. Axonic is the company around Axon framework, and we got Axon server as well, and I'm the lead developer for Axon framework. What I'm going to provide you is a practical journey towards CQRS and event sourcing. But why? Why would you want to have a practical journey towards CQRS and event sourcing? Or why would you want to have a journey towards this at all? You might have some reasons, you might have heard about it, maybe you're entirely new to it. Maybe you went to an earlier talk about event sourcing, you just want to have a clue. Well, I have a journey in mind. So I hope I'm going to take you on this journey, and it's going to make a little bit of sense for you all. So, the first step in this journey is that we, or you, or your team have come up with a brilliant plan. And that brilliant plan you shared with your business, and the business thinks, oh my God, we need to build this. We need to start doing this right away because we're going to have thousands and thousands, maybe millions of users. So you think, we need to start doing microservices. We immediately need to go for that solution. So we need to think about how we're going to structure this, what kind of repositories we use. Do we use different languages? How many teams do we attach here? What kind of infrastructure we're going to use? What databases? All those things crop up, whilst the first thing you had in mind was a brilliant business idea. You weren't thinking about the technical issues. So what you've been doing, instead of focusing on the business functionality, is introducing a lot of non-functional requirements. It doesn't mean that that's not doable, but I'm here to state that that's going to be a difficult road. You can make it, surely, people can make it through Death Valley, but I don't think it's the right way to do things. I think this might end you up, instead of a well-structured microservices solution, into a distributed ball of mud, perhaps. So, instead of taking this road, I recommend we start making a well-structured application, just a single monolith, but with separate modules inside it, a so-called modulith. And if those modules inside it communicate well enough, you can do that breakdown eventually as the need arises. So we need to come up with a way how we're going to do this. So let's first start there. Start building that well-structured application. So we start with a clean slate. And we start modeling our application. We're thinking about services and interfaces and all those things that need to communicate with one another. So we make some lines, we draw some boxes, we give it some reason. But this is not going to be very flexible still. We have interconnected everything with one another. And surely in the basis it is. But on a technical level, we need to cut some of these lines. We need to break them into logical components, come up with a reasonable API between these things, and give them the right level of intent. Give them a form of color, so you will. This is still a single application, but with separate modules inside it that still need to communicate. There's a networking term that is going to help us with actually achieving this, and that's called location transparency. What location transparency dictates is that a component should not be aware of nor make any assumptions about the physical location of the components it interacts with. And I want to strengthen that idea, that it doesn't even have a clue which component it interacts with. Because if your components don't have a clue who they're working with, they can be inside in a single JVM or in several JVMs. It doesn't really matter anymore. So you can make a well-structured app, already make a well-defined API between these things, and, well, first start as a single modulith, and then break it apart if you really need to. So, I've been sharing bits about API, so we need to get a grasp of this. What kind of API would we use here? So for that, I'm going to move over to a different style of my diagram. What we have down below is a UI or an API, a means of entry point into our application, so to say. We got roughly 2 clouds. We haven't got a clue what the actual contents of these are. We just know that one of them is in charge of dealing with the operations, and another one is in charge of providing the information you might need. So the operations end receives a request to perform something, to create, to change, to update, to delete, things like that. It then validates that operation, and if it's happy with that change, it'll change itself, and it'll make that adjustment for future operations to come. But we also need that change on the information end, because the information end isn't, well, making any decisions. It needs to be synchronized. So we need to have a step coming from the operations end to the information end, so that it can provide what data you need. What I'm showing here is command query responsibility separation, or CQRS for short. And what these operations, informations, and synchronization are commands, events, and queries. Using commands, events, and queries as our API is going to help us to achieve the flexibility we require to be able to make a modulif. What CQRS in the basis doesn't dictate is that you make these into actual messages. We know that an event, or I think a lot of people feel that an event is a message, but I also think we should make commands and queries into actual messages. Because if they are, we can extend the bus between those as far as we like, as the need arises. So we're going to make commands, events, and queries actual messages we're going to use. And these messages are going to be the API between the components we have in our application. A command dictates the expression of intent to perform some change inside the domain. Very clearly, the desire to do something, not that something has happened yet. That command is targeted towards somebody that's in charge, and that will validate if that change can happen. Specifically, there's always one instance in charge of this. This is why commands are routed to a single source, a single node in a distributed system even, because somebody is, well, guarding that consistency boundary, giving you the business validation you require. And as a result, you'd either get an OK or a not OK. You don't get the outcome of the query model because we are doing CQRS. So you don't get that from handling a command. You only get an OK or a not OK. As a result of command handling, an event would be published. And an event really is a broadcast type of communication. You subscribe to somewhere where those events are stored, and everybody can read from those if they can subscribe to this source. This is not too different from real world. If you actually go to a news page or the newspaper, everybody can read that. Those are also the same type of facts, history that has happened. Another thing that's important about events is that if you're an event handler and you're not happy about that event or what you're at that moment in time, then that's your responsibility. That event already happened. You can't change the past. You need to deal with the fact that you're dealing with the past. So that's your responsibility. A different routing need from commands, as you might see. Queries are also different in this case because I might be asking somebody about their name, or I might be asking the entire group if you would have enjoyed my presentation afterwards. In different formats, I get different types of responses, and I do always get a response. In a group response, I get some people will respond. Not everybody will respond. That's not too different from code. You don't expect that. So different routing needs, okay? So we're going to do location transparency with these messages, combining it with CQRS to have a separation in our application. We need to start filling in more of the blanks because we haven't got a clue what these clouds are. From now on, we didn't really need to. We're just designing our API. But if you're actually building an application, you need to build those too. This is where a concept comes in that I honestly can't do it justice in 40 minutes time because it's rather complex and I need to focus on other things as well. But what I think is that it's very valuable to combine CQRS with domain-driven design, or DDD for short. And what we will be doing in this case is that we have a model based on the problem space we're in, the domain, and that model just picks the right aspects we need to solve the problem at hand at that moment in time. So you would come up with some grayish blob like we had at first. We still need to give it purpose and color. So we use specific types of building blocks, like entities, like value objects. Events come in here as well. And an important one you would see from DDD is the aggregate, where the aggregate is a group of objects, like entities and value objects, that are considered as one unit when it comes to data changes. They essentially give us a means to protect our business validation because they are dealing with that in one go. So, as I said, I can do it justice. We need to go back to our CQRS diagram and combine this with DDD. Because by combining this with DDD, we have different types of models. We don't just have a single type of domain model. We have a command model and we have a query model. The command model is there to handle the commands, validate the state. So it would only need state required for business validation. And as an outcome of that, it will publish an event. That event is used potentially to create itself, but definitely as a form of synchronization towards other components that are interested in those events. Typically projectors that will project those events in a certain type of query model or projection. The query models can be focused on providing the information that it is required. And we got the flexibility because we're using events in the middle. So we can come up with any format of the query model we like, any storage method of the query model we like. We can go for a relational database if that's what we need. Or if we just want a JSON blob for the UI, why not do NoSQL with just an identifier and that JSON blob if that's needed? Or text-based search, who knows? We got that flexibility right now. I need to focus on the synchronization bit because that is an important topic as well. So we're breaking apart our application. We have a command side and we have a query side. And both have their model types, which they store in the database, the blue box down below. So the command side, it receives a command, it loads its command model, validates its state, and it will publish an event as an outcome. That event is going to a form of a queue, a bucket, whatever. We'll see what it is. I don't really care right now. The query side will read from that bucket, not from the command side directly. It will stream those events in its own pace, meaning it will be eventually consistent, surely, but it is separated. What this is event streaming. We're streaming the events from one end to another to recreate whatever model you like, whatever ordering you'd like to have those events in. Let's change this around a little bit. Let's remove our databases. Although we might still have it on the query side, but we can go with that. If we remove the database on the command side, we still need to be able to load that command model somewhere. Well, we got those events. Why not use the events that a command model has published itself to recreate itself? Just make an empty instance of that guy, load all the events that it has published, and recreate itself. This is what's called event sourcing. And what's of utmost importance if you want to do event sourcing is that you have an event store. Because in all honesty, we have removed or replaced the command database and made it the event store. And the reason I have grayed out the box on the query side is because we can just drop that. We've now got a single source of truth, which are our events. If we maintain those, if we keep those, we can come up with any type of model we see fit at a later stage. So event sourcing, a type of event-driven architecture, and very specifically for recreating the command side. When you're creating projections, that is event streaming. You can deduce what the ordering is. When it comes to recreating your command model, the only event you would use is the events it has published, and that's it. So, we're doing CQRS, DDD, and event sourcing. Having an event store to come up with any form of model we like, doing CQRS to have a specific needs of business validation or providing information as it is required, and using commands, events, and queries as our well-structured API to allow us location transparency to be able to break up our application. But how? I've just shown you how, but this is still rather complex. I'm telling you to do all these things, and keep in mind there are some pros and cons to this as well. If you've seen Andre's earlier talk about event sourcing, you've had a couple. It is a complex beast to tackle. So, let's go back to our well-structured monolith that we have designed. We need to have some glue in the middle, giving us the non-functional requirements of allowing us to have those messages, those buses, the stores, all the modeling requirements of doing and creating an aggregate. And this is where I see Axon Framework as a nice fit. Axon Framework is a Java-based open source Apache 2 license framework giving you the building blocks to do command query responsibility separation or domain-driven design and event sourcing. And at the core of it all, it assumes you're using commands, events, and queries as messages. So it provides simple buses to be able to do this, either in a single JVM or distributed, however you see fit. We've been doing this for quite some time, by the way. Axon Framework has already been around for 12 years. So we have hit a lot of the, well, troublesome roadblocks with this. So this is how we're going to make this practical instead of just a journey about how to do things. And we're going to make this a little bit more practical because I think demos are the better thing of doing conferences like this, seeing how something's actually created. So what I've prepared is an application called Game Rental. So that's the domain it resides in. Games are near to me. I'm an avid video gamer, so this felt reasonable to me. This application, we have a very basic API. We can either register a game, we can rent a game, and we can return a game. Those will reflect as commands. There will also be events stating when that has happened. So a game registered event, a game returned event, and a game rented event. Query-wise, we can either get the full catalog of all the registered games, giving just a list of titles, or we can find a single game if you want to have more information about it, having a dedicated game response. What I'll be using in this demo is, well, Axon Framework, obviously, and I'm going to pair it up with Spring to simplify my configuration greatly. And lastly, what you see up there is Axonic Cloud. What Axonic Cloud is Axon's event store and distributed message bus in the cloud. So one of the products we have, Axon Server, provides you that, being a dedicated event store implementation and a dedicated message bus for commands, events, and queries. You can now also use it from the cloud to simplify your developer needs. So let's actually start doing this. And this is visible enough. That's good. So let me first show you a little bit what I have already prepared. So this is a simple Maven project doing Java 11. I'm using Axon version 4.5.12, and this is specifically a bill of materials. If you're going to start using Axon Framework, I recommend doing the bill of materials because you'll get matching versions, simplifying, well, your life. Other than that, I got some test dependencies in there, also from Axon, using DevTools. The database for a query side is just going to be in memory in H2, because I don't need anything else right now. And I got 4 other ones, which is the Axon Spring Boot Starter to simplify, well, the configuration needs I have. I'm using Data JPA and WebFlux, so I'm going to do a REST UI with Mono and Flux, and Axon's Reactor extension to pair up with that. And then you can see that this is a plain Spring Boot application. Nothing exciting about this. One thing I've prepared is the core API. So what I've been saying is that we're going to make a well-structured monolith, a modulith. Now, making actual Maven modules would be too costly right now, so I'm not going to do that. I'm going to do separate packaging and give privacy to those packages in the right level. The only thing that's going to be public is the core API, because this is what our components are going to talk through with one another, with these commands, events, and queries. So you would always have a package like this containing our messages. You can see we got the events I've been talking about, registered, rented, and returned. Similarly, commands. We got a full game catalog query and a find game query, where the game is the query response to find game. They're pretty straightforward. They're literally just an immutable POJO. So if I have done JDK 17, I would definitely have used records, because that's simplifying me greatly. Or in Kotlin, using data classes. Gotta love them, that's nice. So what we have is state, identifier, title, description, all reasonable things about video games, I'd say. Other than that, just a bunch of getters, equals, and hash code. Not very interesting. The command, on the other end, if we go to the rent game command, apparently we have a game identifier and somebody who's renting out the game. Fair. Other than that, again, it's a regular POJO. There's just one specific Axon thing in here. If you might recall from the messages slide, is that a command is routed to a specific model instance, to a specific aggregate. Here comes the idea of DDD combined with CQRS. So if you're dispatching a command, if you give it to the command bus needs to consistently route this command to the same node that is in charge of a specific aggregate. The way to tell the framework what the identifier is of the aggregate you want to load is by using this annotation. Honestly, there are ways to mitigate away from this and do it differently, but this is the easiest way. Just use target aggregate identifier to tell Axon that game identifier is the field you're going to use to load a query, an aggregate from the repository. Query is straightforward, just the game identifier. You see I'm using constructor properties, so I'm going to serialize with JSON. The game in that fashion is also straightforward. So now comes the time that we're going to introduce a new package. And that package is going to be called command, because I'm going to do CQRS. I'm not going to say that this is the right name, I'm just going to make it clear right now. And the class I'm going to introduce is called the game, because we're revolving about registering, renting, and returning a game. So our command model is a specific game instance that can do the business validation we're going to add here. You can also see I'm making it package private, because I don't want anybody else to be able to access this. So just make it package private. The one Axon thing I need here, because I'm in a Spring environment, to simplify it, is add aggregate. This is not a necessity if you're not doing Spring. You don't have to do this in combination with Spring. But using this annotation tells the framework that this class, well, likely is an aggregate, needs a repository, needs a factory, likely has some message handlers that you want to be registered with the command bus and with your event store to be able to recreate it. So this simplifies my configuration greatly just by using that one annotation. Next to that, I need an OR constructor. This is required by Axon. And I'm going to introduce another constructor. I'll explain in a couple why we need that one, by the way, for the register game command, like so. And by just doing this, Axon still doesn't know that this is actually capable of handling the register game command right now. The way to achieve that is by using an annotation. In future versions, this will be different, I can guarantee you. But right now, you will use an @command handler annotation on the constructor to tell the framework this method is capable of handling the register game command. So in combination with @aggregate, this will register this constructor with the command bus, so that when you dispatch that, it knows how to reach it. This is where our business validation resides. But I'm not going to do any for register game command, because in all honesty, that simplifies my demo. So I'm not going to do that. Instead, we're just going to make the decision that we can publish an event. So in this case, that's build registered event. You can see I've got live templates up my sleeve there. And the way to do this is through aggregate lifecycle.apply. You might wonder, why don't I have an event bus wired here? Well, I want to publish these events within the lifecycle of this specific aggregate because I want to do event sourcing. I want to be able to read the specific stream of events from this exact aggregate instance in the right ordering with the right aggregate identifier attached to those. So I want to publish them within the lifecycle of this aggregate. What I also highlighted is the need of an aggregate identifier. We know the command or the game identifier is that, but the framework doesn't know that. It only knows that from the message, that's how to route it. But it doesn't automatically know this is the game identifier, is the aggregate identifier to the game too. This signals that we need to set some state. And we're not going to do that in a command handler, because a command handler is purely there for decision making, and that's what it does. And the decision is publishing an event. We're going to do this through event sourcing. This is where that no-R constructor comes in, because we need to be able to make an empty instance before we invoke the game registered event, or before the framework invokes the game registered event sourcing handler. You can see just another annotation so that the framework knows this method is used to recreate the aggregate before I move over to handling your command. What we're going to set is the game identifier as an actual field, like so. And again, I need an annotation. I understand that this might not be the most pleasant way if you're thinking about DDD, but we're making things practical. And well, I feel this works. So by using this annotation, I'm telling you that, or I'm telling Axon that this field is used to store the aggregate. So this is the identifier I need to attach to all the events when I'm storing them in the event store. All right, we got the first command handler, first event sourcing handler. Let's add more command handlers for the rent game command. with apply new game rented event, and I now have the game identifier as state, and I need to add the renter as a field. And similarly, we're gonna do this for return. So let's do that like so. And this one is get returner. Okay. I'm not doing any of the business validation I've been talking about. So let's actually introduce that as well. This is a physical game store. So if you're going to rent it, there's just a physical amount of games that you can actually rent out. I think that's fair. So we have a notion of stock we're going to introduce. Similarly, as the owner of a game store, you'll get those games somewhere before they're actually released. So there's a release date attached to this, hence why the game registered event has that. So I think it's fair to also validate whether the release date has been met before you actually rent out the game. And lastly, this store, for whatever reason, requires that if you rent a game, that you're also the one returning it. So we need to validate that too. And right now, we don't have that state yet. So we need to set that state. We need to have a notion of stock first. And that notion of stock is, well, just going to be set here because we don't have any idea of stock in the events or in the commands. We don't increment or decrement it yet. We haven't implemented that yet because we didn't need it. So we do it like so, that there is a single entry of stock. With that in place, we can introduce an exception thrower. So I'm first just going to validate the state. I'm going to check, do I have sufficient stock? And if no, I'll throw an exception. This is a perfect valid, not okay, thrown from a command handler for Axon. If you don't do anything, you see that it is a void. So if you don't return anything, then the framework assumes things went fine. Your command was handled. Everything is okay. But in this case, it's not fine. We're telling the one wanting to rent out a game that, no, there is insufficient items. You can't do this. This also signals another requirement. We need to adjust the stock, because if we don't change it after this event, the game rented event has been published, then people can still try to rent it out. So we need more event sourcing handlers. And this is the moment that you actually add more event sourcing handlers. Up till now, I didn't need any for the other events because I didn't need that state for validation. Our command model is just as lean as what you need for validating, and that's it. So, more event sourcing handlers. For game rented, we're going to do stock minus minus, and I'm going to copy this over again. Game returned, like so. Okay. We've also been talking about that release date, so let's actually set that as well. And you see that I'm setting that from, I didn't want this one, I'm setting that in the game registered event sourcing handler. And the reason I'm doing that here is because this is the initiation event of the aggregate. So this is, to some extent, almost a constructor, I'd say. It constructs our empty instance. Now, this is my personal preference. You don't need to do it that way. This is just how I think it seems reasonable to me. So another validation, just throwing an exception again. And lastly, we got the faulty return a bit, that you need to bun to actually return it. So we need to contain the actual renters of this video game. So we need to store those. So the way to store that is to go when a game has been rented. I'm going to do renters.add event.getRenter. And this is not going to be happy because this field doesn't exist. I'm going to make this a set. No, I'm going to make this a set. Yeah, of string. And I'm going to set the hash set in the game register event sourcing handler. Because, as I said, this is the initiation point of this guy. We also need to remove this. Oh. Renters.remove event.get returner. All right, so we handled all our commands. We're event sourcing this command model. This is nice. So we can move over to actually introducing a query model. Now, I'm pretty certain that based on time, I'm not able to fully code that from scratch. So I'm not gonna. This project has been prepared by me some time ago already, and it actually has several steps to flow through. So what I'm gonna do is move over to step 5. You can do this as well. It's open source. You can just go to my personal GitHub page and actually see this project. There are more steps than this, introducing other things like exception handling or more specifics about Reactor. If you're interested in it, you don't have to, of course. But right now, we're jumping to step 5, because that gives me a query model and an entry point in the UI. So you can see the packages has changed. The aggregate implementation hasn't changed that much. Other than that, I'm using this here. I'm not sure why I did that in the past, but whatever. It's what I did. So, we can move over to the query side. You see, I have kept it simple. I just have one query model. But remember, you don't have to. You can make any amount of query models you see fit. So, what I've done just now is just introduce a game view. Again, package private, because I don't want to share this with other packages, nor do I have to. I'm going to make this a simple entity. Not that interesting, I assume. We have a feeling for this. There's a JPA repository to store this based on the game identifier. Just a regular interface. You might have a feel for this as well. This is going to be our entry point to saving and updating. The interesting bit is, or the more interesting bit, is our game catalog projector. Again, package private, because I don't want anybody to access this. And this is where I'm going to project the events that are happening into our game view. And this is also where I'm going to respond to queries based on the game view, when somebody wants to find one or wants to know the set of titles that are the games that are present. This shows the necessity for the game view repository. I'll be sharing the query update emitter in a little bit. We just have more annotations, actually. We're just telling the framework that by making this an event handler annotated function, again, just void, because we can't, well, not be happy with this event. It happened. We need to deal with this right here. And we're just going to save it in the repository. These annotations on their own don't tell the framework that it needs to register this class as an actual event handler. That's what we do by just making this a Spring Bean. If you're combining Axon with Spring, Axon will check all your beans if they contain message handling functions on startup, and it will register those to the right buses. So by having this class contain an event handler, it will be registered with the event bus to stream those events, to recreate itself. It will do a similar step for the query handlers we have below, but then just, well, to the query bus. Operation-wise, on a game rented and returned, we find an entry, and if it's present, we increment or decrement. If it's not present, we throw an exception. In all honesty, you would assume that our events are handled in order. The framework does this for you as well, but you have the flexibility to change the sequencing ordering of these events, because you're in charge of configuring that consumer. I'm not doing that right now, so I'm basing myself on the basics, but, or somebody might have in the middle just thrown away. Yes? Asynchronously. Yeah. Sorry? Event, yes, there is an event bus just inside the framework, but it can also be something outside of it. That's a configuration flexibility you have at a later stage. Yep. We also got our query handlers in here, which do return actually something. So when we're finding a game, we're returning a game response. I'm very clearly mapping here because I don't want to share how we're storing our query model. That's not something I want to publicly share with the outside world. I want to keep that for myself. I've designed a specific query API, a response for this. So I'm just mapping it to that response. And for a full game catalog, I'm just mapping the titles and storing them in a list. So that's the query side of it all. Let's go to the UI. We got a very bland game DTO, which I'm going to open up. Other than that, this is just a REST controller on a /rental. And this is the entry point into our query side and our command side. So this is going to dispatch commands and queries. So you'll be using the command bus or the query bus, but instead I'm using the command gateway and the query gateway. These are friendlier APIs the framework provides you to make it a bit more simple. The actual bus is the dedicated implementation, which either might be inside your JVM or distributed or asynchronous or with other paradigms you would like. And I'm using reactor-specific variants so that the responses are mono and flux. So I can combine this with webflux so that it will subscribe whenever needed. So here you see again, register, rent, and return. And I'm just doing command gateway.send, and I get the mono back. you see that registering a game does return something, because this creates an aggregate. So you return the aggregate identifier. The framework does that for you. The other ones are void, because we just want to know whether it was successful or exceptional. On the query gateway, you're using the methods query to do a direct query, because we're pointing to a single source, getting a response back. You can also see that I'm required to provide what I'm expecting to get returned. If I have a single instance, it's just the class. If I want to have plural instances, I use multiple instances of. If I want to do a flux, a stream of data, I can use Axon's subscription query. So the query gateway can subscribe to getting updates as they happen, which is very powerful. It allows you to mitigate eventual consistency issues by just subscribing to the query model and get it as soon as it's there, so that you don't have your UI to be, well, synchronous. This requires one thing though, because the framework doesn't automatically know when a new title has been added. This is where that game catalog projector comes in, or the query update emitter comes in, I should say. The query update emitter is Axon's means so that you can tell it, I want you to emit an update to, in this case, the full game catalog query based on a certain predicate. Well, I just send it regardless to whomever has done this query, and I'm going to send the update. So, with this in place, we need to actually start it up, I think. I think that's only fair. And this is where Axonic Cloud comes in. So in this case, I'm using a distributed variant of the command bus, the query bus, and the event bus, and an actual event store from the cloud. So I'm going to log in with my own account. You see I've got a dashboard, and I need to introduce a notion that's called a context. So you can have several of these where your applications reside in. In this case, I'm going to make a context which I'm going to call game rental, like so. I need to define the type of cluster I want. I'm just going to do a shared one because I can be together with others, that's fine. I'm going to place it in Belgium because that's the closest one we provide right now. The context type, you can see there's a developer, which is just going to be thrown away, which I'm going to be using. You can have a single node. There's a price attached to this, obviously, or multi-zone, so that you can be, well, failover based on regions or zones, if you will. For now, developer is fine for me to just play around a little bit. So I'm going to create this context. It's there. And now I need to actually, well, get the keys to connect my application to this. I need to make an application binding. So I'm going to do that over here. I'm going to call the application binding game rental as well. And I need to select the context to do this in. Once I save, I get properties, which are essentially the keys to the house to connect to Axon Cloud. So I can actually use those distributed buses and event store. So with this in place, I can go to the application properties. You can see I've already got it selected, and there we go. And right now, I'm going to pray that the demo gods are nice to me and that everything works. So, parsing and running. Let's select it. Oh, that seems to have been started up. That's good. This should net me some information on the dashboard up here. So I can, hey, let me go. I can go to the dashboard. I can see that my game rental application is connected. I can see that I have some command handlers. I can see I have some query handlers. And here is Axon's bit to actually handle events. That's called an event processor, giving you a ton of non-functional requirements to configure. Right now, it's automatically 16 separate threads that will handle events on their own, stream those events whenever they see fit. Okay, I've also got an event store in here, which I can query if I like, but it's empty because we haven't done anything yet. So let's go back to here. What I've prepared even further is IntelliJ, well, HTTP files to actually run a bunch of things. So I'm going to register games like Doom and Command & Conquer and Halo. You might be aware of those, or you might not be. I'm just going to run all of them. And, well, everything passes. And we should have an identifier as a response to these, actually. I don't see it right now, although that's okay. Let's not linger on that too much. We'd at least have our events, so things have happened. We can even eliminate some of the fields to make that a little clearer. We see a sequence number of those. We see that they're all tied to the game. That's fine. I don't have any revisions right now. I don't care about the timestamp or the metadata. That's all supported automatically. Just want to see one of those games. And I can open it up, and I see that, well, I got my payload. That this is Legend of Zelda, apparently. Okay, let's actually see the other operations also succeed. That would make it a successful demo, I'd say. So we're going up. I've got a means to find a single game, in this case, Elden Ring. Well, this works, that's nice. If I find a non-existing game, I should get an exception because it's not found. That's good, this worked as well. I can find the full catalog. All right, we got all the games here that have been registered. Let's actually see some of those commands succeeding and failing. So let's assume Allard is going to rent out 1, 2, 3, 4. Just an OK, just as we like it, because we don't care about the response other than OK or not OK. And I can rent out game 5, 6, 7, 8. OK, sure. Let's actually see that fail if Stefan E wants to rent the same game I have rented. This will give me an insufficient items in stock. That's good. Or a game that hasn't been released yet. Similarly, this fails because it's not been released yet. Nice. Now, if I return my own game, because I'm done with playing it, but I also want to return Allard's game because he asked me to, well, I should get an exception because I'm not able to, because I'm not the returner. All right, let's go to the last one, which is actually watching that stream of data going through. So the Flux did its thing, and it should still be running, and I should be able to see that actually. That's a shame. If I actually register this, yeah, I got the other one still open. I now also got The Last of Us Part 2 attached to it, which I just registered, so that kept open. Okay. This should also have made some changes in the event store because we have, show it to me, because we have more events. Would be nice. We see some of a sequence number in here, as you can see. So this is me returning game 5, 6, 7, 8. All right. This is what I wanted to show. So I can move back to my slides. So I've given you a practical journey towards CQRS and event sourcing with the onset that we would be doing microservices to some extent. And we haven't. We're still not there. We still just have a monolith. And honestly, I think that's fine. This can already be complex enough to just get the business validation that you wanted to implement. Let's first start doing this and then eventually think about how you're going to do this in microservices if you really need to. So that's what I had to share. Thanks for attending this. I truly hope you enjoyed it. I've got some links up top here with some valuable information, like the GitHub link where this project is at, so that you can jump all those steps yourself. You can go to the framework, Exonic Cloud. And the only thing I didn't mention just now is start.exonic.io. That is, in all honesty, just start.spring.io, but then with a framework flavor attached to it. So again, thank you. I hope you've been enjoying JFocus and you will the coming days. If you have any questions, I think this is the time. Yeah. Yeah.
Thank you for the presentation. So my question is regarding the event bus itself. In the Axon framework, is it only limited to the bus it provides, or can you replace it with something else like Apache Kafka?
I wouldn't call Apache Kafka an option, honestly, but yes, you can replace it for others. So how it's been set up is that there are just interfaces for everything. We assume that an event store is actually a specification of an event bus implementation. So if you would open up the interface, you see it implements event bus, giving those additional benefits. The plain implementation that's present, I've already told Axon Framework has been around for 12 years. That was just relational database. Just doing this through JPA or JDBC, because in most cases, that is fine. There's also a Mongo variant we provide. And the only reason I'm calling Kafka out not as a true option at this stage is because it doesn't not ideally support event sourcing, getting those separate streams per aggregate. You'd either need to have separation per aggregate identifier. Yes, there are means to mitigate against this. I feel it's using a hammer for a screw. So right now we don't have that. I'm very deliberately saying right now, because who knows how things might change in the future. It is open source after all, so if you feel there's benefit, you can change it. So what we do provide is a dedicated extension. We have several extensions for the framework, like this Mongo bit I've been talking about. There's also a Kafka extension, which you can just use to stream those events. It's just not a replacement as an event store right now.
Thank you.
Yeah, sure. A no is fine, of course. Or you can always comment. towards me afterwards, I'm fine with that. Yeah, if that's it, then thank you.